Hello everybody! So where I live, I have planes that fly over my house all the time. I'm on the route to a runway. They're flying away, they're flying in, or whatever. Anyhow, let's do a problem involving planes. A plane is flying directly away from you at 500 miles per hour at an altitude of 3 miles. How fast is the plane's distance from you increasing at the moment when the plane is flying over a point on the ground 4 miles from you? This problem might seem really hard, but we have, techniques to deal with this. So the first thing we're going to do is draw a picture. So let's draw this picture. So we have the ground, here's the ground, and maybe you're standing right here, and your height, we're assuming your height is sort of insignificant in the problem. And let's see, the plane is 3 miles into the air, so this is supposed to be 3 miles. And here's the plane's flying. Here, there's the plane flying, and its velocity is 500 miles per hour. So remember, velocity is the derivative of position. So P prime of t is equal to 500 miles per hour, and we want to know if this is suppose this is the airplane. The airplane's right. This is my picture of the airplane. The airplane's right here. This is P of t. And let's see. Oh, and the airplane is at a point 4 miles away from you. You want to know how is this distance increasing? And let's call this S of t miles. Now that we have a picture, we need to find an equation. So to find an equation, you should start by looking at the picture that you drew. Now, how's this picture going to help us? Well, one thing you should try to see is, I see a triangle in here, and since the airplane is directly above you, or directly above the point that's 4 miles away from you, that's a right angle. Aha! We're going to use the most famous theorem in mathematics now. We're going to use the Pythagorean theorem to write down a relationship, and it's going to say, well, P of t, that's the point here, that's this distance here, plus p t squared plus 3 squared is equal to this distance here, S of t squared. There, this is our equation. Now that we have an equation, we need to differentiate the equation. All right, so let's look at our equation, and we're going to differentiate it with respect to t. So we're going to take the derivative with respect to t. And to do this, we're going to be using the chain rule all over the place. So P of t squared, that's going to be 2 times P of t times P prime of t. And the derivative of 3 squared, well, that's 0, so it's gone. And now let's take the derivative of S of t squared. Well, this is going to be 2 times S of t times S prime of t. The equation is now differentiated. Now that we've differentiated the equation, we need to evaluate the equation at desired values. Alright, so let's look at the equation that we just differentiated. And look, we know some of these values. Okay, so P of t, if we look at our picture, P of t is 4 miles. So this is going to be 2 times 4 times, well, what's P prime? P prime is 500 miles per hour. So that's going to be times 500. And this is equal to 2 times, well, what's S of t? Aha. I'm not sure what S of t is, but I can use the Pythagorean theorem to solve for it. Check this out. Let's get another color out here so I know. Look, it's a right triangle where one side's 3, the other side's 4. This is a right triangle. Well, this has to be 5. It's a 3, 4, 5 right triangle. So it's 2 times 5 times S prime of t. Now remember, we want to know S prime of t. So it's going to be, what's 2? It's going to be 2 times 4 times 500. 2 times 5 is 10. Divided by 10 is equal to S prime of t. And we can simplify this a little bit. We have 2 times 4 times 500 divided by 10 is equal to S prime of t. And now, so that's, if we do this, it's going to be 2 times 4 times 50 is equal to S prime of t. And let's see, 2 times 4 is 8. 8 times 50 is equal to S prime of t. What's 8 times 5? 8 times 5 is 40 times 10 is 400 is equal to S prime of t. And this is 400 miles per hour. So if we go back to our original picture, the distance the plane is leaving us, or the rate that the distance is increasing, or the velocity from this perspective, from this on this line, is 400 miles per hour. All right, so we've solved this problem involving planes flying and stuff. It's time to do some more math.